Every day, we wake up with the same brain, but we don't have to end the day with the same one. The truth is, your brain is a changeable machine. It can evolve, reshape, and optimize, but only if you know how to focus. And when we talk about focus, we're not talking about forcing yourself to sit still or stare at a book. We're talking about a biological force, one that rewires neurons, sharpens memory, and unlocks potential. Let's talk about 5 signs of the right focus style, backed by neuroscience, and inspired by the teachings of Dr. Andrew Huberman. Focus is not just a mental skill, it is a biological mechanism deeply embedded in how the brain changes. In neuroscience, the concept of neuroplasticity refers to the brain's ability to rewire itself based on experience and attention. But neuroplasticity is not something that simply happens automatically. It is triggered by specific states of mind and body, and among the most important is the state of focused attention. When someone is deeply focused, they enter a unique neurobiological condition that allows the brain to encode information, strengthen connections between neurons, and even build new ones. This is not just a philosophical idea, it is measurable, scientific reality. To focus is to tell the brain, this matters. That single message, communicated through the act of intense attention, activates neuromodulators in the brain, especially acetylcholine and norepinephrine. These chemicals serve a critical role. They mark certain synapses, or connections between neurons, as important. Once those synapses are tagged, the brain is far more likely to return to them later, reinforcing them and making the pathway stronger. It's a little like highlighting key lines in a book. Those parts are easier to find, reread, and remember. In the same way, focus highlights the specific neural circuits you want to build. There's also a temporal dimension to this. When you focus, your brain doesn't immediately lock in and change. It starts a process. The actual rewiring happens later, usually during sleep or periods of rest, but it only happens because you first engaged in focused effort. If you go through the motions of learning or practicing something without true attention, the brain sees it as noise and filters it out. In contrast, when you concentrate, the brain knows, this is signal, not noise. This is something we should store, something that should shape the brain's architecture. What's fascinating is that focus is not just about the mind, it begins in the body, particularly through the visual system. The eyes aren't just passive windows to the world, they are active parts of the brain. When you deliberately focus your eyes on a specific point, like the words on a page, the steps in a workout, or the details of a presentation, you trigger a cascade of neural events that align the brain for learning. The pupils constrict slightly, breathing changes, heart rate slows down, and the brain enters a more alert, attentive state. This physiological response is what allows for the deep encoding of new information. It's not metaphorical, it's mechanical. There is also a crucial psychological element. Focus is not easy. It requires discipline, intention, and sometimes even discomfort. The brain does not change under conditions of ease. Neuroplasticity is strongest when there is what researchers call cognitive strain, that feeling of effort when you're pushing just beyond your current capacity. It's the moment in a math problem when you're confused but trying, the instant in a workout when your muscles shake, the pause in a difficult conversation when you're choosing to stay engaged. That strain is not a sign that something's wrong. It's a sign that something is working. It's the very condition the brain needs to initiate change. And yet, our world is full of distractions. The average person checks their phone dozens of times a day. They scroll, swipe, and split their attention constantly. This kind of fractured focus makes it nearly impossible to engage the neurochemical systems required for learning and adaptation. It's not that the brain is broken. It's that it's responding to what it's being trained to do, shift quickly, react often, and never go deep. To reverse this, and to truly change the brain, one must reclaim focus as a daily practice. That practice doesn't need to be long. Even 30 to 90 minutes of deep, undistracted focus a day can have a profound effect. The key is that the focus must be intentional, effortful, and supported by the right biological environment, proper sleep, hydration, light exposure, and breaks. When you get this combination right, the brain becomes more plastic. It learns faster, remembers more, and functions better. And over time, that adds up not just to new skills or knowledge, but to a new self. Focus, then, is the gateway. It is the first step toward change. You don't need more hours in the day, you need more moments of real attention. Because where attention goes, brain change follows. And where the brain changes, life changes. When we speak about focus, most people assume it's purely a mental phenomenon, something that happens inside the brain. But biologically, focus starts with the eyes. The visual system is not separate from the brain, it's part of it. In fact, the retina, located at the back of the eyes, is actually brain tissue. It's the only part of the brain exposed to the outside world. This means how you use your eyes can literally change your brain's internal state. This is one of the most overlooked aspects of focus and attention, and it's something deeply rooted in how our nervous system evolved. The human brain is wired to interpret the world through vision first. When we are in a relaxed state, like when walking through a park or scrolling on a phone, our eyes tend to move around freely, and we engage in panoramic vision. This kind of broad, unfocused gaze puts the brain in a low alert state. It's good for creativity, daydreaming, and rest. But it's not the state you want when trying to learn, change, or concentrate deeply. To enter a focused state, one of the fastest and most effective ways is to shift to what's called convergent visual focus. In simple terms, this means fixing your gaze on a single point. When you deliberately focus your eyes on a specific location or object, you initiate a cascade of physiological changes. Your pupils adjust, your breathing rate alters, and your level of internal arousal increases. The brain shifts from a relaxed, diffuse mode to a highly alert, concentrated one. This is not about willpower, it's about activating a different neurological mode by controlling your vision. There is a direct pathway between the visual system and the areas of the brain responsible for alertness and attention, such as the locus coeruleus and the basal forebrain. When your eyes lock onto something, those areas release neuromodulators like norepinephrine and acetylcholine. These chemicals sharpen your mental processing, increase signal-to-noise ratio in the brain, and make it more likely that what you're paying attention to will be remembered and stored. In other words, vision controls focus, and focus controls learning. This connection between the eyes and the brain's alertness systems is especially powerful because it's under your conscious control. You might not be able to instantly control your thoughts or emotions, but you can control where you place your gaze. And that simple act can shift your brain into a completely different gear. You become more alert, more ready to encode information, and more biologically prepared to change. It's important to understand that this is not just a hack or trick. This is how the nervous system has always worked. In a survival context, when humans needed to find food, spot danger, or hunt, their eyes would lock onto targets. That narrow focus would trigger a state of heightened awareness and readiness. The same circuits still exist today, and we can engage them deliberately to enhance our ability to focus in modern tasks like studying, problem-solving, or creative work. But there's a cost. This kind of narrow focus can only be maintained for limited periods of time. The brain and visual system can't stay locked in indefinitely. This is why most people find that their concentration wanes after about 45 to 90 minutes. That's not failure, that's biology. The brain needs rest intervals to reset, and the eyes play a role here too. After a period of intense focus, allowing the eyes to relax and return to panoramic vision helps downregulate the arousal system. This cycle, focus through visual locking, followed by release through visual relaxation, is how the brain maintains balance. There's another layer here as well, fatigue. When people overuse their focus systems without breaks, the neuromodulators that support focus get depleted. You might feel mentally foggy, irritable, or unable to concentrate even when you want to. That's a sign your system needs recovery. Again, this starts with the eyes. Stepping away from screens, looking at distant objects, and giving your visual system a break can help restore balance faster than just sitting and thinking harder. So if you want to increase your ability to change your brain, whether that means learning a new skill, overcoming a habit, or building a new mindset, you must understand that focus is not purely mental. It begins in the body. It begins with how you use your eyes. By learning to control your visual attention, you can directly influence the biological systems that govern your capacity to focus, learn, and transform. It's not about staring harder, it's about using your vision wisely. That's where true focus begins. Focus is often portrayed as a passive state, something you either have or don't. But in reality, focus is an active, energy-consuming process that places demands on the brain and body. One of the most revealing aspects of true focus is that it doesn't feel comfortable. In fact, the sensation of friction, strain, or difficulty is not a sign of failure. It's a sign that your brain is actively trying to rewire itself. This strain, this cognitive effort, is not only natural, it's necessary. Without it, learning doesn't take root. Neuroplasticity, the ability of the brain to change in response to experience, happens most reliably when we push ourselves just beyond what feels easy. This discomfort is a biological signal. When you're struggling to solve a problem, fighting to stay engaged with a difficult task, or resisting the urge to check your phone, your brain is activating the very circuits that enable change. It's easy to think something is wrong in those moments. The urge to quit, to switch, or to delay is strong. But according to the science, those moments are where the magic happens, when the brain, under pressure, begins to adapt. Inside the brain, what's happening during these moments of cognitive strain is quite extraordinary. Neuromodulators like acetylcholine and norepinephrine are being released in concentrated bursts. These chemicals act as spotlight operators. They highlight specific neural pathways and say, this is where the attention is, strengthen this. This is the foundation of neuroplasticity. The areas of the brain receiving this heightened attention become more sensitive to change. The neurons fire more consistently. The synaptic connections strengthen. New pathways are formed, and old, less useful ones are weakened. But here's the key, all of this only occurs in conditions of mental effort. What's more, the brain doesn't distinguish between the strain of focusing on a math problem and the strain of trying to stay off social media while working. Both are forms of internal resistance, and both activate the same circuitry. The difference is how we respond to that resistance. If we surrender to it, the brain learns to take the easy path. If we push through it, the brain learns to tolerate effort and value long-term goals. This is crucial because your brain becomes what it practices. The more you engage with difficulty, the more capable your brain becomes at handling challenge. The more you avoid it, the more fragile and distracted your focus becomes. The discomfort of focus is a biological reality, not a failure of willpower. It's an evolutionary feature designed to prioritize energy use. The brain is a high-cost organ. It only weighs about 2% of the body's mass but uses nearly 20% of its energy. So it's wired to conserve resources whenever possible. When you focus deeply, you are demanding that the brain spend more energy. It doesn't want to, unless it knows the task is important. That's why meaning and motivation matter. When something feels purposeful, the brain is more willing to allocate the effort. But regardless of the task, the presence of effort is a requirement, not a flaw. There's a common misunderstanding that if you're struggling to concentrate or feeling mentally fatigued, you're doing something wrong. But the neuroscience tells a different story. Those sensations mean you're exactly where you need to be. You're at the edge of your capacity, and that's where growth occurs. It's like resistance training for the mind. Muscles grow by being challenged, not coddled. The same is true for the brain. However, it's important to balance this strain with recovery. Prolonged, unrelieved cognitive effort without breaks will lead to burnout, not growth. The brain needs cycles, blocks of focused effort followed by intervals of rest. This allows the neuromodulatory systems to reset and prepare for the next round of plasticity. Ignoring this balance reduces your ability to sustain focus over the long term. The takeaway is simple but profound: friction is feedback. When you feel the struggle of concentration, don't run from it. Don't label it as failure. Recognize it as the signal that your brain is in the process of changing. Learn to stay with the discomfort a little longer each time. By doing so, you're not just completing a task, you're reshaping your mind, building new capacities, and enhancing your ability to adapt. And that, in the most literal sense, is how you change your brain through focus. The brain's ability to focus, learn, and adapt is deeply influenced by how we structure our time. There's a widespread belief that the longer we work or study, the more productive we become. But neuroscience paints a very different picture. The human brain is not designed to maintain intense concentration continuously for hours. Instead, it performs best in defined intervals, specific cycles of high attention followed by rest. These natural patterns of mental energy are known as ultradian cycles, and understanding them is one of the most effective ways to optimize focus and drive neuroplasticity. Ultradian cycles typically last between 90 to 120 minutes. During these periods, the brain's ability to focus, process information, and adapt is at its peak. After this window, cognitive function declines, stress hormones begin to rise, and mental fatigue sets in. It's not a failure of motivation, it's a biological rhythm. Forcing yourself to push through these dips often leads to diminishing returns, poor retention of information, and a higher likelihood of distraction. On the other hand, working in alignment with these cycles boosts efficiency, learning capacity, and overall brain health. These rhythms are governed by fluctuations in neuromodulators, chemicals that influence how alert or receptive the brain is. In the early stages of a focus cycle, chemicals like dopamine and acetylcholine rise, creating a fertile state for deep concentration and learning. This is the ideal time to engage in tasks that require problem-solving, creativity, or memorization. But as the cycle nears its end, these chemicals begin to deplete, and other systems, like those responsible for fatigue and stress, take over. When that shift happens, it's a signal to pause, step back, and allow the brain to reset. This rhythm-based approach to work is not just about efficiency, it's about neuroplasticity. The brain changes most effectively when we focus deeply and then let go. Intense attention acts like a spotlight, tagging the circuits involved in the task. But the actual rewiring, the strengthening of connections, the creation of new links, occurs in the aftermath. During rest periods, especially when combined with sleep or even quiet reflection, the brain processes what it experienced during the focus cycle and begins to embed it into long-term memory. This is why people often have breakthrough ideas when they're away from their desks, walking, showering, or daydreaming. It's not laziness, it's biology. The default mode network of the brain, which becomes active during periods of rest and introspection, helps consolidate information and make new associations. So rest is not the enemy of productivity. It is an essential partner in the process of learning and growth. The problem arises when people ignore these cycles. In modern work environments, there's pressure to multitask, stay constantly connected, and work long hours without breaks. This leads to chronic overstimulation, shallow focus, and reduced ability to learn. Instead of entering deep focus states, the brain remains in a scattered, low-efficiency mode. Over time, this weakens attention span and resilience. To counteract this, it's important to design your day with intention. Schedule focused work in 90-minute blocks, eliminate distractions during that time, and then take real breaks. During these deep work blocks, it's critical to protect the brain's attentional bandwidth. Turn off notifications. Put your phone out of sight. Use noise-canceling tools if necessary. The more you can create an environment of single tasking, the more likely your brain is to enter the high-performance state necessary for plasticity and learning. Then, once the block is over, step away, physically and mentally. Look out a window, go for a walk, close your eyes. Let the visual and cognitive systems recover. This rhythm also applies to longer cycles, such as days, weeks, or months. Just as your brain needs breaks during the day, it needs rest periods built into your lifestyle. Overworking for weeks without pause can lead to burnout, just like pushing beyond the 90-minute limit can lead to brain fog. Respecting these rhythms at every level is a way of cooperating with biology, rather than fighting against it. In the end, the structure of your focus is as important as the content of your focus. It's not about how many hours you grind, it's about how intelligently you work within the natural timing of your brain's energy systems. Working in blocks, respecting recovery, and minimizing distraction doesn't just make you more productive. It turns your time and attention into tools of transformation. Through this deliberate pattern, you create the ideal conditions for your brain to learn, adapt, and ultimately change.